There is a shortcut, and I'm going to quote this because it only works for simple linear factors, and we'll talk about this here in just a second, without repeated factors, all this kind of stuff. So it has a very small scope that it works for. However, it is there, so I'm just going to show you. So if we were to look at example 1, right, we were integrating 3x squared plus 7x minus 2 over x cubed minus x squared minus 2x dx. I just want to show you what this would look like. So we know, because we've already done it, that this factors to x times x minus 2 and x plus 1. When you set this up, 3x squared plus 7x minus 2, we'll go ahead and just write this out. X times x minus 2, x plus 1 is equal to a over x. Oh my. Gotta slow down a little because I'm getting crazy. A over x, b over x minus 2, and c over x plus 1. We've seen this already, right? Now, here's the kicker. You go back through that same step where you multiply through with your common denominator, but this time leave everything factored. So I've got 3x squared plus 7x minus 2 is equal to a times x minus 2, x plus 1, b times x and x plus 1, and c times x and x minus 2. Because here's the shortcut. You can't see me, but I'm air quoting this shortcut method. When you are looking at this shortcut method, you look at your zeros. Of these simple linear factors, you look at the zeros and you say, okay, given these zeros, how am I going to figure out my A, my B, and my C? So you go through them. You're going to let x equal 0. We'll start off with that. You are plugging that into both sides of this equation. So you're looking at this equation and you're plugging that in. So you have 3 times 0 squared plus 7 times 0 minus 2. A times 0 minus 2, 0 plus 1. B times 0, 0 plus 1. C times 0 and 0 minus 2. I just wrote it all out because I wanted you to see what I'm actually doing. So what this actually gives you here, because this is obviously 0, 0. And here's what makes this happen. 0 times anything is 0. 0. Actually, I'm going to do it like this. So 0, 0. This whole thing is a 0. This whole thing is a 0. The only thing I'm looking for here is being able to solve for that A. Do you see that? So negative 2 is equal to A times negative 2 times 1. So A is equal to 1. Straight up right there. All right, I'm going to scoot this up. Now, oh my. Hang on. Craziness is going on. We're going to let x equals 2. Now, whenever I look at this, here we're actually plugging this in, right? 3 times 2 squared, 7 times 2 minus 2. But look what happens. Anywhere I have this x minus 2 factor, those are going to be zeros. So I have 0 plus b times 2 plus 1 plus 0. So I'm not going to write all that stuff out. Right? So look at your number over here on the left. 4 times 3 is 12 plus 14 minus 2. Right? And I could look at this as 12 minus 2 is 10. 10 plus 14 is 24. Or however you want to do that. And then I've got 3 times 2 is 6. So this is 6b. So b is equal to 4. You see this? So it is a handy shortcut if you can get in its tiny little scope. As long as you can get in its tiny little scope, then it works out pretty good. I rarely ever use this, full disclosure, simply because Rarely do you have this nice tiny little scope. But, pardon me, but it's worth looking at just because 3 times negative 1 squared plus 7 times negative 1 minus 2 is equal to, now again with the negative 1, so I know this is going to be a 0, this is going to be a 0, so now I'm solving for C. So 0 plus 0 plus C times negative 1 and negative 1 minus 2. So I've got 3 minus 9, so it's negative 6. And then I've got negative 3 times a negative 1. It would just be positive 3. So divide both sides by 3, and C is a negative 2. Now, with my partial fractions, I am going to integrate my A, which is 1 over x, my B, which is 4 over x minus 2, and then my C, which is the negative 2 over x plus 1 dx. All right? So it cuts a little bit of time down, but honestly, I don't know that it cuts a whole lot of time down. So then obviously this is the same. I'm not going to integrate this again. So this is the same as what we did. So I'm showing it to you just because it's cool, but I rarely, if ever, use this method just because you don't always get a nice simple linear factor to work with. You get lots of other options that go with it. Okay, but it's always just good to know. Knowledge is